So I got a request from the ed of ed to do a comparison between the keyword actuation mechanism on the Monroe Model G and before and the Model K and after, because they made a somewhat significant change between the two models. They still work basically the same way, they just made a change that was more efficient to produce the parts, but the actual principle is still the same. So I've got my Monroe Model G here, upside down, and this is, Model G is the same as, in this particular area, is the same as the Model F and before, at least back to the Model D. So let's take the bottoms off of both of these. And we can take a look inside. So as we're looking at already, you can see the differences here. So these are a significantly different stamped piece than these. And the way that these work is, up there you can see a disc, and if I move this, the disc moves. So there's a disc on this side that moves this way, and then this one rocks the other direction and moves another disc opposing it. You can see that one moving back there. One disc has 5 equal length pins sticking out of it. You can kind of see the pins on it there. And then the other one has 4 different length pins on it. And basically, like if you want to add 5, this will push over to engage that disc with the 5 pins on it, and it'll add 5 into the register. Or if you want to add, say, 3, this will move over to its second furthest position, engaging the 3 shortest pins, and add 3. And if you want to add something above 5, then it's some combination of both of these. Like 9 will engage all the pins on both discs to add 9 total. And it's the same principle here. You can see up in there the discs as well, which these ones you can't really. There you can see the pins on that one, the different length pins. So basically, the change that was made in between these two models is what determines the distance that these pieces rock. So on this model, it might be kind of hard to see from this angle, you can see it here, the key stems themselves have varying slants on the bottom of them. So for example, I guess you can see, hopefully see down in there, this one all the way at the bottom has a very slight slant. This one has a slightly more, slightly more, slightly more, and then none, because this one, the slant moves over to this side to engage the 5-pin roller, or the 5-pin wheel, and then this one has a slight slant, and then a slant on this side, which would be 6, so it's 5 plus 1, and then so on all the way up to 9, which has the steepest slant on that side, and the 5 slant on this side. So when you push a key down, those slants will pinch these together, or pinch just one, and engage the appropriate number of teeth on the rollers. In this machine, however, see if you can see, but all of the key stems are the same, and these stamp pieces here actually have varying angles on tabs on them. So you can see how there's a very narrow, the tab on this is barely bent out at all, versus up here the tab is bent significantly out, and there's a missing tab here, and then this pattern repeats up here for 6 to 9. And then same thing on this piece, there's no tabs on these first few, and the last few have the tabs. If you can see down there how the tabs are missing here, and then they start here. And what that allowed them to do was, instead of having to make 9 different keys plus 2 different rockers, they only had to make 1 type of key and 2 different rockers. So basically, they took an assembly that had 12 pieces per column, or 12 different pieces per column, and changed down to an assembly that had 3 different pieces per column, which would, you have a lot less dies and different stuff like that, and you have a lot less part sorting and everything. So, just a gaining efficiency there. And that's basically all it is. There's no advantage to either mechanism other than it's just a lot more efficient to make this one than this one. So, I got grease all over my hands. Let me clean that off, and then I'll push some keys, and you can see how each of these work. So I'll come back over to the Monroe one here, or the Model G rather, and you see I'll push this. This should be the 6 key, I believe. So I push this. You can see how they both moved a little bit. If I push 9, you'll see how they both move all the way in. If I push, say, 5, only one will move. And then 6, they both move a little bit. Well, this one with the 5 is either moving or not moving. There's no variation in the distance that it moves. So it always moves the same amount when it does move. Same thing here. If I push, see, this is the 1 key. So that one moves just a little bit. If I push the 4 key, which is this one, see, it moves a lot more. And the same idea here. See if I can reach under here. I didn't prop this one up as high, but if I push, say, the 4 key, same principle. The left one moves, the right one doesn't. If I push the 5 key, the left one moves back out to not engaging, and then the right one moves in. If I push the 9 key, they both move all the way in. That's back to rest. That was 8. It's 9. So yeah, basically the same idea, just a more efficient way of manufacturing it. And you can also see, the significant differences in the structure here, how this one is, mostly stamped steel frame with just these 2 cast crossbars and a couple of cross pipes and everything, like these standoffs here, versus this one is mainly a cast iron frame and then just has this cast iron shell. Whereas in here, the outer shell, like this side and this side, actually support different pieces of the mechanism. So definitely it's the difference there. But other than that, pretty similar principle among the machines. So you got the 3 gears here, which correlate to these 3 gears here, even though these are larger. The keyboard clearing is different. And you also see the carry mechanism back here, pretty similar. Actually, this is the one that has the pivoting end pieces here. So these end pieces, I'll do a better description of this in my Monroe Model D video if you want to get a better description. But these end pieces are free floating between 2 end stops, and then they can either pivot back and do the carries behind the shaft when the shaft is rotating one direction, or when the shaft rotates the other direction, then they pivot the other way and do the carries behind the shaft. Versus in here, not behind the shaft, but behind the first part of the helix. Versus in here, looks like they have 2 carries either side, so it's a true full helix for both addition and subtraction. But anyway, that's about all I got to say about that. Hope that was pretty clear on the differences in the little demo there. And if you're questioning why some pieces look like they're missing out of this machine, this is just a parts machine. You can see the frame is cracked back here. It's supposed to have, actually this side is cracked too. There's supposed to be a shaft all the way in the back here, but this part of the frame is cracked. Looks like this is also cracked back even further. So this is just a parts machine, but this part of the mechanism is complete enough for me to demonstrate. So that's what I did. So hope that was clear on how all that works, and hope you enjoyed this video, and thank you for watching.